Hi guys, this is Chandrakala, studying Computer Science and Engineering in MSRIT. In this video, today I am going to demonstrate the installation process of the Rattle GUI tool. Now I am going to explain you the Rattle GUI. What is Rattle? Rattle GUI is a free and open source software package providing a graphical user interface for data mining using the R statistical programming language. Rattle is used in a variety of situations. Coming to area of specialization of a Rattle. Rattle is basically a data mining tool. Data mining is the analysis step of the knowledge discovery in database process. The overall goal of the data mining process is to extract the information from the dataset and transform it into an understandable structure. Data mining is a logical process that is used to search through a large amount of data in order to find a useful information. Data mining technique is used to find the patterns that were previously unknown. Once these patterns were found, then those patterns can be further used to make a certain decisions for the development. This data mining technique involves mainly three steps: exploration, pattern identification, deployment. Exploration is a step in which the data is cleaned and transformed into other form, and the nature of data based on the problems are determined. Second step is a pattern identification. Once the data is explored, refined and defined for the specific variables, it identifies and chooses the patterns which make the best prediction. Third one is a deployment. Deployment is nothing but the patterns are deployed for a desired outcome. About Rattle. Data mining which combines the concepts, tools and algorithms from a machine learning and statistics for the pre-analysis of a very large data sets. A Rattle is a graphical data mining application which is written in R and providing a pathway into R. Rattle has been developed specifically to ease the transitions from the basic data mining as necessary offered by the GUIs. Rattle represents the statistical and the visual summaries of a data. It transforms the data that can be readily modeled. It can build both supervised and unsupervised models from the data. Rattle is one of the several open source data mining tools. This is directly available within R. Rattle, which provides the considerable data mining functionality by exposing the power of R statistical software through a graphical user interface. Rattle is used as a teaching facility to learn the R software language. Next, I am going to explain you the installation process of the Rattle. To install the Rattle, first we need to download the R window. R window can be downloaded from the website as a cran.rproject.org. Instructions for downloading which can be available in a website called as a rattle.togware.com. There are mainly two commands to install the Rattle in a R programming language, which are install.packages of Rattle. Next one is a library of Rattle. Now I am going to show you how to download the R window. This window gives the option for downloading the R for a Linux, OS X and for a Windows. Now I am going to download R for a Windows. Next, click on the install R for the first time. It has got a newer version 3.2.4 for a Windows. Click on the download R for a Windows. Save the file. Once R has been downloaded, we will get the exe file called as R. Now we are going to run the exe file. on run. Choose the language in which you want to install. Click on next, 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 next. Is going to install R for a Windows. It will take some time to install R. Once installation is done, click on finish. Once R is downloaded, now I am going to demonstrate R using a GUI called as a Rattle on top of it, which will remove all the requirements of coding in R. First, what I am going to do is I am going to launch R over here. I have got a desktop icon. Click it on. This is what R window looks like. Now I am going to launch a library called as a Rattle. Then Rattle. Since Rattle is a data mining tool, it's basically a GUI that reuses a lot of data mining and a lot of algorithms and the various other libraries that already are part of R. So there are mainly two key benefits of using R over a Rattle. One is from learning standpoint, if you are either getting started with the R or getting started with the machine learning. Rattle specifically uses a simple tab-based concept for a user interface, capturing a workflow through a data mining process with a tab for each stage. A typical work progresses from a leftmost tab, that is a data tab, to the rightmost tab, that is a log tab. For any tab, the idea is the user to configure the available options and then click on the execute button here. This follows the various methodologies like a data exploration, testing, transform, clustering, associate, and modeling, finally evaluate, and the final one is a log model. This log window which shows that all are commands, in case if you want to look at the syntax as well. Now I am going to demonstrate how to use the Rattle on top of R to build a predictive model. First, go to the file name, click on. This will give the type of file which you want to import it. It has got various files like a CSV file, text files. I can import Excel files. I can also import the Excel 2007 files. I am going to import a CSV file. Since I have got a dataset called as a diabetic data.csv, open, then press on execute. Now I can see the variable names which are come over here. Imported it as a spreadsheet. I can also import through a ODBC connection, connect to a MySQL server and pull it out from there or from already defined R dataset, etc. Since I have already imported a CSV file itself, now what we see over here is that we have got all the variables of the data type of a different data types. The first one is input data type. Input means They are supposed to be used as an independent variable or inputs to the model. The next variable is a target variable. Target refers to a model which the variables properties or which variables are we are going to model over here. Optionally identify another variable as a risk variable, and other roles include a ident and the ignore variables. Rattle uses a simple heuristic to guess the roles, particularly for the target and the ignore variables. In our data tab, Rattle allows for a dataset to be partitioned into a training, validation and testing. This particular option is called as a partition. This is an interesting option over here. This allows me to partition the dataset into a multiple parts, up to 3 different parts randomly. So we can build a model in a one part and test out the predictive part of the variable on a different variable. So now I am going to partition the dataset in such a way that 70% of the dataset to be built on the model and the 30% of the dataset is going to be used for a testing. So I will give a 30% for a testing. Then the third variable is keep it as a 0, since 70 plus 30 is a 100%. Therefore I have given a 0 for a third sample. Now I am going to explain you the exploration tab. Exploratory data analysis is important in understanding our data. The Explore tab provides a numerous numeric and the graphical tools for exploring the data. In Exploration tab, we have got a summary, distribution, correlation, principal components and the interactive. Summary option uses a rSummary command to provide the basic univariate summary. This is augmented with the contents and the describe commands of HMISC package. Now I am going to demonstrate how a few graphical capabilities of R and Rattle. So if I go to the Explore tab, here is the distribution. Now I am going to use something called as a box plot here. It's a very interesting graphical technique to check out the distributions and the central limit of the variables. I am going to check it for a patient number. I click the patient number in a box plot and press execute button. This shows the very interesting plot over here. I trace the box plot for a patient number. Since I have got a readmitted variable as a target variable, hence it is plotted patient number versus readmitted. There are number of patients who have got readmitted for more than 30 times, and there are number of people who have got readmitted less than 30 times. There are some of the people who got readmitted at all the times, and there are some of the people who not yet got readmitted. This graph will shows this star marks indicate median of the graph. According to our data set, 5 crore people who are not yet got readmitted. This is about the box plot. We also have the histogram plot, cumulative plot. I will show the demo of the histogram plot for a patient number. Press execute button. This is a histogram plot of a patient number. This red color bar indicates the less than 30 times the patients got readmitted. This green color indicates the more than 30% of the people got readmitted, and this blue color indicates that there are no people who have got readmitted. We can also generate the plots by using the bar plot, dot plot, mosaic plot, etc. Coming to the next tab, that is the test tab. The test tab provides access to a number of parametric and the non-parametric statistical tests of a distributions. This is the most recent addition to the Rattle which continues to receive the attention. Tests of the data distribution include the Kolmogorov-Smirnov test and the Wilcoxon-Rank sum test. For testing the location of an average, t-test and the Wilcoxon-Rank sum tests are provided. The f-test and the Pearson correlations are also available for the testing. Cleaning the data and creating a new features occupies a much time for a data miner. Hence, we have got a transform tab. Transform tab, there are many approaches of a data cleaning, and R programming language, it supports all of them. Rattle's transform tab provides a number of common options for a transforming, including the rescaling, imputing the missing values, recoding, and cleaning up of the observations or variables. First one is a rescaling. The rescale option offers a number of rescaling operations using the scale command from the base and the rescaler command from the reshape package. Rescaling includes a recentering and a scaling around the 0. Scaling 0, 1, robust rescaling around the 0 using the median, and rescaling based on the groups in the data. Imputation of a missing values is a tricky topic and should only be done with a good understanding of the data set. The observation data which contains the missing values. In our diabetic data set, there are many variables. There are around 50 variables in our data set. Like a patient number has got a unique value as a 71,000. Mean has got this much of a mean variables and the median values. The variable race has got around 2273 missing values. This is about the imputation. Data mining algorithms are often described as being either descriptive or a predictive. Rattle currently supports the two common descriptive approaches to the model building. Those approaches include clustering and the association analysis. A variety of predictive model builders are supported. In a cluster analysis, we can see the k-means clustering. K-means clustering is nothing but it is an analysis which will identify the groups within the data set. It has also got a hierarchical clustering. Next one is association. Association rule analysis is it identifies the relationships or affinities between the observations and between the variables. These relationships are then expressed as a collection of association rules. Next one is the modeling. Modeling includes the variety of predictive model builders which supports the decision trees, boosting, forest, support vector machines, generalized linear models, and the neural networks. Decision tree model. A decision tree model is one of the most common data mining models. It is popular because the resulting model is easy to understand. The algorithm uses a recursive partitioning approach. Since in traditional algorithms, it is implemented as a R-part package. It is comparable to the C-art and ID3 of C4. Next one is a random forest model. A random forest develops an ensemble of the decision trees. Random forests are often used when we have a large training data sets and a large number of input variables. This random forest model is typically made up of tens or hundreds of decision trees which built using a random sample of a data set. The next one is a boosting model. A basic idea of the boosting is to associate a weight with each observation in a data set. The next one is a SVM. SVM is a support vector machine model. A support vector machine searches for so-called support vectors. which are data points that are found to lie at the edge of the area in space, which is boundary from one class of a points to another class. The next one is linear and generalized linear models. The next part is a neural networks. A neural network model which is built on a base, that is idea of a multiple layers of neurons which are connected to each other, feeding the numeric data through a network, which combining the numbers to produce a final answer of the dataset. Next tab we have the evaluate tab. Evaluate tab, which contains the error matrix and the risk matrix, cost curve, hand, lift, ROC and the precision, which is used for a positive predictive value. An error matrix which shows the true outcomes against the predicted outcomes. A error matrix is also known as a confusion matrix. The last tab of the Rattle window is a log tab. Log, which tells a GUI is not a complete and a flexible as a full programming language. A Rattle is sufficient for many data miners in providing a basic point and click environment for quick and consistent data mining, gaining much from the breadth and depth of R. Rattle, which supports this through a log tab. Log tab captures the commands for a later execution and is also educational. Informative comments are included in the steps involved here. These log file captures all the interaction of the R commands. This log files includes generally a records that processes the building model of the dataset. This is about Rattle GUI, which is built over a R. Let's look at the advantages of the Rattle GUI. Rattle is the most comprehensive statistical analysis package which is available in R. A Rattle is a free and open source software which allowing anyone to use and importantly to modify it. Rattle GUI is compatible with all types of files. As I explained before in the installation process, it can import text, CSV and Excel files. Rattle is a cross-platform, which means a Rattle can be run on any of the operating systems like Windows, Linux, Solaris, etc. It also got limitations. The quality of the packages is less than the perfect. Although if a package is useful to many of the people, it will quickly evolve into a very robust product through a collaborative efforts. Documentation is sometimes patchy and it is impenetrable to a non-statistician. This is all about the Rattle. Thank you.